Today we will introduce the third part of the probability distribution. It's also a part of the continuous probability distribution. Is the exponential probability distribution. Okay, the exponential probability distribution is useful in describing the time it takes to complete a task. Okay, so usually we will use it to describe the time between the vehicles arrive at a toll booth, or the time required to complete a questionnaire, or time required to load a trunk, or the distance between the major defects in a highway, or just like today in the morning, the time between two students arrive at our classroom, or the time for you required to walk from the dormitory to the classroom. So usually in waiting line applications, the exponential distribution is often used for us to know the service time. Okay, that is to know the interval between the two services. Okay, their time could be in what probability distribution. And in such condition, we will use the exponential probability distribution to describe it. So the exponential probability distribution, if we would like to learn it, we just like we had introduced the uniform probability distribution or the normal probability distribution, the first one thing we need to know is the exponential probability density function. Okay, and here you will find the density function looks not so friendly as you can imagine. Okay, but here you need to know mu represents the expected value or the mean. Okay, and the E means Euler number is around 2.71828. You can calculate this formula, okay, by your calculator, by your cell phone, or by the computer. But the next is, if you would like to know the probability of the X, okay, you cannot just only know the probability density function. You also had to calculate it. So that means if today we give you an X, and then we will let you know if the X is less or equal to a specific value of the X, then you will calculate it by the cumulative probability formula. Just looks like this one. Okay, so a probability cumulative functions looks like this one. You don't have to hard to memorize it, but you need to know how to use it. Okay, and the property of the exponential distribution is that the mean and the standard deviation are equal. So today, if you know the mean of the exponential probability distribution, you will also know the standard deviation because they are equal. And this concept is similar to the Poisson distribution we introduced last week. Okay? So let's use this example to introduce the application of the exponential probability distribution. In such example is the time between the arrival of cars, okay, at AI's full service gas pump follows an exponential probability distribution with a mean time between the arrivals of 3 minutes. And AI would like to know the probability that the time between the two successive arrivals will be 2 minutes or less. Okay, so today you will know it's in a mean time for a specific event. It's the arrival of it is 3 minutes. Okay, so follow our cumulative probability formula here. The X0, that means the specific value of the x is 3. So today we would like to know the x less than a specific value. But here, that is, today we would like to know is the two successive arrivals will be 2 minutes or less. Okay, so I have to revise what I have talked about the cumulative probability. That is, the x0 should be the 2. Okay, because today we would like to know the probability for less than 2 within such conditions. So follow in such formula, the x0 would be the 2, and the mu, okay, mu is the mean or the expected value. So here it would be 3. Okay, because here in the question it tells us a mean time between the arrival of is 3 minutes. So we use the probability as less than 2 minutes. Okay, less or equal than 2 minutes is used to minus the Euler number, and with the minus x0 divided by mu, or mu equals 3. So we will get such results. That means the probabilities for two successive arrivals less than 2 minutes, okay, is in such gray area is 0.4866. Okay. So the last part we will talk about is the relationship between the Poisson and the exponential distribution. They look similar, but they still have some difference, okay? Especially for the exponential distribution, it provides an appropriate description of the length of the interval between the two occurrences, okay? For example, the two students enter into the classroom, okay, and you will find the length of them arrive at the classroom, it would have a length of the interval. So we will to calculate the probability, okay, to describe the length of the interval between those two students they enter into the classroom. But for the Poisson distribution, they would to describe in an interval, in a time interval, okay, and how many occurrences or the number of the occurrences happened, okay, in such interval. They want to know the description between the occurrence of such results. So you need to know the probability of the number of the occurrence in such interval. So that's the most difference between the Poisson distribution and the exponential distribution. The one is focused on an interval time, the number of the occurrence, and for its probabilities. Okay, and the second one is to focus on the two occurrence, okay, two occurrence, and to calculate the length of the intervals, and to calculate its probabilities. Okay, so that's for our today's introduction about the exponential distribution. Thank you.